We're going to look at different exponential and log functions and graph them. So looking at the exponential examples, if you notice that the graph kind of just curves up, so it never actually touches the x. It continues on forever and ever and ever, but it never will cross the x. But it does cross the y. So the exponential crosses the y, and it depends where, depending on the h and the k. So the h and the k still apply to exponential and log graphs. Remember, it's opposite h and same k. So for our domain, it will always be, the exponential will be negative infinity, positive infinity. So it's never ending to the left and right. Domain is based on the x. Our range, where does it, near the 0? So 0 will be the range, and then up negative infinity. So it'll go all the way up, 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 up. X-intercept, there will never be an x-intercept, and the y-intercept, in this case, the regular base graph is 0, 1. And we're going to play around with that with the h and k, so the y-intercept will change depending on the kind of curviness of our L. So now looking at the log, so how does it differ? So if you look, it kind of flipped. The log graphs actually touch the x, so there will be an x-intercept. So the base log equation will be 1, 0 as our x-intercept, but it never touches the y. So if you notice, it goes all along the y, but it will never ever cross. So there is none. And so for our domain, how far to the left it goes? Well, 0. And then how far to the right is positive infinity. And then our range, how far down? Well, it never ends going down, so that's going to be negative infinity. And how far up? Well, our L never ends upwards, so that will be positive infinity. So let's kind of look at it and compare it and add some H's and K's. Okay, so let's look at some exponential equations. So I typed in y equals 5 to the power of x. So if you notice, it still touches at that 0, 1. Now let's add some h's and k's. So the opposite h, same k. And remember, the h is going to sit next to, kind of in the parentheses with the x. So let's add that. So we'll keep the same base so we can kind of compare. And then let's add x minus 1. And where does it go? So it's that red line. So you see that we did minus 1, but it's opposite. So it went to the right one. And then let's do y equals base 5, exponent x plus 1. And it went to the left one. So opposite h, and that sits inside the parentheses. So now let's look at some k. So let's do y equals, let's still do the power, 5x and then plus 3. And then y equals 5 to the power of x and then minus 3. All right, so k sits on that outside, and it's the same k. So the plus 3 is the green line, so went up 3. The blue line went down 3 from the y-intercept. So the k is vertical and our h is horizontal. So that's the exponential graphs. So now let's look at a log graph. And again, the h and k still apply. So opposite h, horizontal, same k. So here I put in a log graph, and it never touches the x. I mean, it crosses the x, but it never touches that y line. So it's opposite of what we were just working on. So now let's kind of tweak it and add let's do x minus 1. And then let's do x plus 1. So you can see, so our normal line is the red, and then the minus 1 went to the right because it's h, opposite h, it's inside the parentheses, and the green one went to the left one. So now let's add a k so we can kind of compare. Let's do x plus 3, and that went up 3. So from our base equation, it went up 3.